Okay, part two. So where were we? So we were talking about what? The difference between async and sync and async, which is about blocking versus non-blocking. And in async mode, you would have is concurrent, so not necessarily parallel. The distinction is between concurrent and parallel. And that if you want to do concurrent stuff, you can do it with processes on multiple threads, and that would be done by the OS. So that would be called OS preemptive, this type of multitasking. Sometimes OS actually has cooperative multitasking, which is the stuff that we are looking at now. So cooperative multitasking means that your application will be in charge of relinquishing control to the operating system in order for it to decide when to switch tasks, to switch programs. So that was the case for Windows up to Windows 95, I think Windows 95, 98. Maybe even XP was cooperative multitasking, because the CPUs didn't have the hardware capabilities to support preemptive multitasking. Starting from NT, of course Unix and these guys have preemptive multitasking. That is considering if the interruption is done by the operating system. But with async programming as a library with green threads and what we're talking about here, we are doing cooperative multitasking at the application level. All right, so let me put this stuff on the side. So that's, I think, the summary of what we did so far. All right, and we have this example for cake, where we make this cake, right? So before we get into this point here, I want to talk about something called generator functions. So that's actually not 100% related to async, but I think it's going to be easier to understand once we go through generators and actually also iterators. So generators and iterators are pretty good concepts that we should know about. Iterators. Sorry. So the idea of starting from iterator is when you want a function that returns more than one element. So for example, you want a function that calculates a sequence of numbers. Let's say a Fibonacci sequence or whatever. Any sequence of numbers, doesn't really matter. Let's say the sequence is, you can return a list of numbers, right? So you can, for example, return the first 100 primes by making a function calculate primes. And then you will return this in Python. You will be returning as a list, and every programming language has the notion of a collection of elements. So if it's a list or it's a vector, so what we're talking about is or an array, right? So it's just several elements of the same type. The one thing with these kind of data structures is that you are allocating memory for the elements, and you basically need to know beforehand how many elements you want to return, right? So if you have a function calculating prime numbers, you would have to pass like numbers. Okay, I want 100 first primes or 200 first primes. Obviously, you cannot say I want all the primes, because nobody has infinite memory and infinite time. It would not be possible to actually finish this function. This sequence is infinite. So what instead you could do, instead of saying that, okay, I want a function, you don't always want to passing this number of elements, right? So let's say, for example, that you want to find the first prime that is less than a million. Oh, no, sorry, more than a million, right? The first prime more than a million. So you don't exactly know how many primes you would have to generate, right? So you could try like, okay, let's try 100, and then, well, it doesn't work, I need more. So you call a function again with, okay, now it's 200, and that's really inefficient, because you will have calculated the first 100, And now when we need the 200, then you recalculate the first 100. And then maybe 200 is not enough, so you keep doing that until you actually find the right number, right? So that's pretty ugly to do it this way. So another way to do it is actually return an iterator, right? And in Python, all of these languages have this concept of having basically an object that has the current value, but then you have a method that says, okay, get me the next one, right? So this works well if you have something that is infinite, because you have the current value. Let's say that I want the same example. I want to return the first prime that is greater than 1 million. So I'm going to create a function that returns an iterator of primes. I will look at the first prime. Is it greater than 1 million? If so, yes, I've got it. If not, then I would ask for the next prime, and then keep on doing that until I exceed 1 million. So the interesting point of having a function like that is that the function that actually calculates the primes doesn't need to know about how I'm going to use it. I don't need to code inside that function that actually I'm looking for primes that are greater than 1 million. And I could be reusing that same function in different contexts, right? Because at the end of the day, it just has to know how to return the next prime following a given prime. And it also works well because this way I can have some kind of data structure that represents a list that is infinite. And the key here that it is possible to have something infinite because I'm calculating primes lazily. My function is not obviously going to generate all the primes, which is impossible. It would generate a prime on demand, right? So the interface of that function, of that iterator, okay, so the function returns an iterator, right? So it returns an object that has a particular interface, which is the iterator interface. And typically an iterator interface has a type, underlying type. It has is there next, so that returns a boolean, and then next, and that returns a t. So you would ask whether the iterator is at the end. So there's other ways to make the iterator, but this is the I believe the Java API for iterator. Okay, in C++, an iterator would have there are several kinds of iterators, right? This one is the most basic one, which only allows you to go forward. So some iterators allow you to go forward and backwards. That's not the one I want. Iterator in Java. Right. So yeah, the interface is has next and next. So it has a bit more. You can remove stuff, but that's not really necessary for that kind of purpose. And this I think was added for each remaining. So the main guys are this has next, which indicates whether you reach the end of the iterator. So if the sequence actually is finite, then this eventually will return true, and in which case you're not no, it returns false, and in which case you should not call the next function. Okay. So that's what an iterator is, right? And what about generators? So generators are pretty recent, well, at least in programming language. The concept of generator is really old, actually. But most languages didn't have generators. And to my knowledge, the first popular language to support generators was Python. And then it was adopted by C#. And now it's coming to several other languages. So what is a generator function? So generator function is actually just a function that returns an iterator, and it's written in a way that looks like you don't have to do that much work to return an iterator. Okay, so that was not very precise, right? But let's put it this. Let's have an example. So our example is again this prime number function. Well, actually, I don't know how to calculate primes, right? But let's do things that it would be similar to a prime, but just a function that increments. So you will return 1, 2, 3, 4, 5, 6, 7, and so on and so forth, right? So if I write it the classical way, so my series would be, I want to return a series, right? And I know that my series is an iterator. Okay, so here now is becoming a pseudocode, because this stuff does not really compile in JavaScript. It doesn't know what iterator is really. But the idea here is that I will have to return something that has these two methods. So has next, right? So has next would be a function that returns a boolean. So let's say return false, and then the next that is a function that returns a value. All right, so what's going on here? Okay, so the syntax is wrong, but not sure why. All right, and then okay, so obviously this itself will just always return 1, right? So somehow I need to keep a counter of the value that I have. Let's say counter, right? And then do something like this dot counter equal counter plus 1. Okay, so this actually is very terrible, because you cannot really do this. You have to bind this and so on and so forth. But I think the idea is okay. So the only idea that I'm trying to show here is that running an iterator from scratch is not an easy task, right? Because what you need to do really is this function here has to return the next element of your sequence. So you have to keep track of where you were, and if it's some simple enough, like getting the previous value plus 1, then you just need to store that previous value. But if it's something more complicated, like calculating primes, then you basically have to store everything that you need to go to the next step, right? And it's pretty error prone. A lot of code here would be written so that you keep your state in this object, and then you return an iterator on that, right? So actually, the better way to do this is through this generator type of functions, right? So generator is a function that looks like you're running a normal function, right? Let's say in that case would be while true, and then I have a counter, and then I do counter plus equal 1, and I want to return this counter, right? So if I do that, you will see that obviously this is not what's going to happen, right? Because if I call series just like this, this is going to come here, it's going to go counter 0, then while true, increment the counter, and then return. So I'm going to get out of this function returning 1, and that's it. That's the end of the story, right? If I call series again, it will come back at the top, go through this logic here, and return 1 again, right? There's really nothing that is kept between invocation of this function, right? So this is not returning a sequence, it's just returning the first element, which would be like 1, right? So what I want is actually that function to be transformed into something that maintains progress, and this is what basically a generator function can do. So I think in JavaScript you have to put a star, and you have to yield instead of right. So this all I did here is to mark the function as a generator, So with this star in Python, there's another logic, another marker I forgot. And instead of returning, I say yield, right? And there's definitely something that has to happen behind the cover. So this function is not going to be like a normal function anymore. What happens is that when you call series, first the signature is not going to be a number anymore. It's going to be iterator of number, right? Even though I'm returning a number here, in fact, what this function signature is going to be is iterator on number. Right? And what happens when I call series is that it enters a function like before, goes here, but when it sees the yield counter, which replaces the return counter, it's going to return the value to the caller, like before, but it's going to do something more interesting. It's going to store all the variables that were in use and their current value, and store that into an object that is going to be carried back to the caller. Right? And then with the caller now has an iterator. So I'm calling series, right? But what I receive is going to be iterator on series, right? If I call iterator next, actually only at this point would the function be invoked. It would this call here actually doesn't do anything. This one is the one where I'm actually asking the series to generate the number, right? So it would come in and then do this code here until it reaches the yield and return that value, right? So this is going to return me 1, right? And then if I call iterator next, right, the series will resume from the function series will resume from where it left off. So after that line, after the yield, and it will look back to here because there's a while true. Counter will be incremented, and then it will yield the next number. So again, the iterator will return the second number, which is 2, and then will be again suspended. Right. So basically, if you keep doing this call iterate next, you're gonna get all the numbers in sequence, and only when the function term exits, so either through the end here, but it's not going to happen because my while true is not, there's no break. But assuming that there's a way to exit from that loop, when we get out of series, then the iterator will return has next false, and basically the sequence is finished. So the beauty here is that this code is very simple to understand. It is written as normal sequential code, but we have these yield points where basically the compiler has turned that into a suspension point. So it knows that when I see then it sees a yield counter, this is a point where the function should break out, but it's also a point where the function should come back. So these generators are related to the concept of a coroutine. Right? So coroutines. So a routine, which is like a function, a routine of functions, pretty much the same thing. Typically, you will come from the top, and then you exit at the bottom, or you exit because there's a return statement in the middle. But the point being that you go through the entire you go through the function, and then when you call that function again, you will start from the top. There's no way to start from any place else than the top. Right? And the coroutine is different because it basically allows you to suspend execution and resume it where it left off. In general, coroutine are more powerful than that because you could enter at anywhere and you could exit anywhere, right? Well, not anywhere, but you could exit at several points and you could enter at several points. So it's like a generalization of a routine. The routine, you're forced to enter from the top, and when you exit, you cannot come back from anywhere else than the top. Right? So these generators are just one type of coroutine. where you have to enter from the top, but when you leave, you can come back from there, right? All right. So why do we talk about these guys? We talk about these guys because sorry, the way the async block works. So we have seen these async blocks here. It's very similar to a generator function, right? But why? So let's see that whenever you see a function that has a star, and we have async instead, right? And whenever we yield, we have await instead, right? So these guys are pretty much matching. Await matches yield, and that star here that marks the generator function is gonna be we're gonna use async to mark that the function is async. And the reason why we need to do that is because, as you saw earlier, using these words actually does a lot of things underneath, right? It transforms this function into a function that returns iterators, and also it introduces a lot of logic to save the state at the yield points and to resume at these yield points. So if you look at the code that is produced by the compiler when it sees something like that, it's quite different from what you see here. There's a transformation, which shows the async transformation, and it was interesting to see how it works, because before JavaScript supported async, these transformations had to be emulated by like a plugin. So in basically the old days, if you wanted to use async await, you had to use like a transpiler that converts JavaScript to JavaScript. So JavaScript advanced into like more basic JavaScript, and that particular transpiler was going to it was transforming this async function into something that is sequential, is normal function, right? And in order to do so, it would find all these points and introduce state variables and that stuff, right? So I'm not going to go to more details than that. Just say that this generator function, whether it's async or it's a star, has a huge impact on the code. Right. So now what we have here is something very similar to what we have here. When the function is called, when we use process, this is actually not going to return. Well, it's not a normal function, because if it was a normal function, it would go here and then it would see this await hgate async, and then we know that this async may take a while, right? So Node.js is very famous for having this model where most of the stuff is async, and specifically if you are doing network communication. In this case, it's talking to a database, so it has to go over the network, so it's inter-process. It will use async model. And even for simple things like reading a file, opening a file, writing a file, it's also going to prefer the async model. Not that it doesn't have a synchronous API, but the normal one is the async API. So what you get here is that when we reach this line, it's equivalent to this yield counter, right? So the control is actually going back to the caller. So if you are calling process from outside, or in this example you say bake cake, it's gonna start the baking the cake, but then make cake, which is okay. So we have to make this guy async, right? Async, and then we have to make this guy await, right? So when we reach bake, the caller to make cake is gonna get back control. The function returns, right? So if I do make cake, for example, 2 times, then you would crack the egg, whisk the egg, and add the flour and start and do the bake. But then I would see crack egg, whisk eggs, add flour of the second cake, right? So before you see eat cake, you will actually see the cracked eggs for the second cake, right? Because this await bake takes 1 hour, right? And then we can start baking preparing the second cake, right? So you will see. Okay, let's make it easier. Right? You will see with egg, add flour, and then you see start bake, and then you will see with egg, add flour, and start bake, and then after about 2 hours, 2 hours, you will see bake, and then eat cake, right? So why 2 hours? You can say, wow, I should have like 1 hour. Yeah. Okay, so okay, where was I? Yeah. So you would think that how is this stuff working, right? How is that stuff? No, we know that when we reach a with bake, we're already getting out of this function, right? This pretty clear how we can make whisk egg and add flour 2 times, right? Because we know that like this guy, we enter here, we reach this point, we got out, right? So, but when am I gonna eat my cake, right? This seems like how would it know to call this to call and resume these functions, right? So this is where we have our event loop and our event loop coming in, right? So the thing is that you cannot put a weight on anything, right? You cannot put a weight on a function that is not asynchronous, and at the end, eventually, this await will come to something that is going to be a primitive function, right? Because you're not awaiting. You have to await on something that is going to be awaitable, and awaitable is like circular definition, but something is awaitable is there's a way for the operating system for the program to know that stuff is ready. If I do await bake and there's an oven, there's no way for my program to know that the oven is ready, right? That the cake is ready. So what I can say is I can await for the file to be read, or await for a certain time to pass, or await for receiving something from the network, right? So all these things are asynchronous because I do not know per se when it's going to happen. Arguably time you can know, but the rest you cannot know when it's going to happen. But what your program can do when it awaits is to put a notification, a waiter. We call them a waiter, like a waiter. That's a pretty weird name, but a waiter on that particular thing that we want, right? So let's say, for example, then bake is simulated by sleeping for 1 hour. So when we reach here and we say await sleep 1 hour, 1 hour, something like that, this function is going to be a primitive function, right? If you implement this function yourself and you don't have any access to special logic, then you're kind of stuck, right? Because how can I actually wait for 1 hour without the way to wake you up when that hour comes back? So the answer, you can't, right? What you're going to do is you're going to say, please function, put a notification so that after 1 hour there's an event that is coming back to me, and that event would be that this particular code is ready, can resume, right? So all these the points where when you have an await, the program will go back to the caller, but before it goes back to the caller, it registers an event handler so that when that particular task completes, which is like either sleep 1 hour, or when I receive the data from the network, or when my file is read, whatever. When the stuff that I'm waiting for is ready, then my task can resume, right? So the compiler is smart enough to basically turn this guy here into a call to next, right? We didn't have that before, right? If we look at the logic of this series here, we know that the compiler can turn the code that was sequential or normal, like normal function, into an iterator. So, and each task, each element is one progress of the function. But we still need to have something that actually calls next, right? And the stuff that calls next for async functions is this executor, right? So, to rewind what we're talking about, right? When you do make cake like this and make cake, the two make cakes, the first make cake goes here and then reaches the await and the sleep. That sleep is gonna create an awaiter on a timer and put that task on hold, knowing that after 1 hour the task is ready to resume, and the task ready to resume would be to continue execution of that make cake, right? And then so that code, the continuation is not executed at this point. So we resume and we have a second make cake. Then we have again whisk eggs, add flowers, and then we enter the sleep again, right? So it's also gonna sleep for 1 hour, right? And then when it resumes, it's gonna resume from this point. So what is actually at this point, because these two times overlapped, right? And then I actually didn't do anything between these two guys. We are going to wait only 1 hour, right? Because we started this await about the same time, considering that these two guys are very, very short, right? So we started sleeping 1 hour, so we registered that task like now plus 1 hour. A few milliseconds afterwards, we entered this guy here, and then we registered again another sleep for 1 hour, but starting 1 millisecond later, right? So then 1 hour and 1 hour 1 millisecond afterwards, we're going to be eating eating cake 1 and eating cake 2. So in this case, what I said was wrong. We would sleep basically 1 hour and a millisecond, right? And now you may say, well, I know we know we are resuming from this one, right? But when can we resume, right? We know that after 1 hour it's allowed to resume, but on which? What if I was doing other things, right? What if I was actually in the middle of a long process, long calculation, right? And that one takes 2 hours, right? So would it be able to interrupt the long calculation in order to eat the cake? Well, ideally you would want to, right? You would want to, but this is not going to happen unless you have done the same logic here inside a long calculation, and you have sprinkled points where you are also awaiting, because we are talking about cooperative multitasking. So the multitasking in this mode will not be able to switch between tasks, right? So this is task 1, and then task 1 is broken into like subtasks, right? We cannot switch between these tasks at any point other than these await points, right? So if long calculation is the normal function and takes like 2 hours, then even though these two guys here, these cakes are ready to be eaten, there is no point where you will be able to eat your cake, right? So you will have to wait for this calculation to be over, right? And then you get, in that case, you get at the end of the code. And this is also where Node.js is a bit different. I think probably Python is a bit different. the program will not exit. The program will not like finish because we reached the end. It sees that there are two tasks, the two cakes that that we have to eat, and it will invoke these functions. So the resume points would be either at the point where you have a wait, or when the program has nothing else to do, right? And the center part of this logic is this even loop, because basically what what this stuff does is that it has an infinite loop. Like this code is like pseudocode, but it's provided by Node.js, right? And this guy is going to say like get event, right? And then process event, right? And then right. So this get event is where when the cake is ready, the cake ready event comes back, and then we can process it. We can like go and eat the cake, right? And this loop executes every action that every task that is ready in some order. I think the order is not guaranteed, right? But it means that you run this guy, and until there's no more task, the program will run, right? And specifically, if your program is a web server, like this one is a web server, because we have this app listen, it queues a task that never terminates, right? So we are listening to a socket 3000, and we're listening to incoming connections, even though we don't have anything after, and it's the end of the program. Because we have that guy listening and basically queuing task, the program will not terminate and keep on listening for work, right? And that's because Node.js has this implicit even loop, right? So yeah, that's pretty much it. Oh, another thing here is that we said here that we didn't talk about promises. So promises and futures is the only last thing that is we need to know. Promise and futures. So when I said that the async function, that the generator function returns an iterator, likewise an async function returns a special type of value, and it returns what's called a promise. Right. So if you return return like 1, like return 1, then that guy will return the signature will be promise of number, right? So it's a parameterized type based on the type of the value returned by your function, and again, that is automatically done, right? So similarly to the generator function, which return an iterator, here you will return a promise, right? So what's this promise? So the promise is actually very similar to an iterator, except that it's one value that is encapsulated into an object. So the encapsulation is the promise, and then the value is this number guy, right? So what we are saying here is that there's no way for this function to return a value right now, right? Because if you call process, you're gonna go here and you're gonna do this stuff, right? And until you reach the return 1, the value is not ready, right? You have to do all this stuff before the value is ready, right? But yet you have to exit the function, right? Because we know that when you read a wait, the caller is gonna get something from process or from make cake, right? So what is that value that make cake will return? It returns this promise, which is basically a ticket, right? So if, for example, the very equivalent part here is that you go and you actually, this guy is a bakery, right? You may and you order a cake, right? So you order a cake, and this whole process will take an hour, right? But you need to know that it's your cake and not somebody else's cake, right? So what you're gonna get is a ticket number. You're gonna get a receipt for basically making that call, right? And the receipt would have an order number, but it doesn't have the cake, right? You don't have it yet, right? But what you can just ignore the receipt. So what we did here is ignore it, right? We just get the cake when we get the cake. But with the promise, you can do other stuff. You can start chaining them, or you can start waiting on them, right? So one thing I could do is, since this function is returning is an async function, I could also do a wait and then a wait, right? So in that case here, the second one is not going to be triggered, not going to start until this whole function is completed. Oh, sorry, not this one. This one is completed. So the main difference here is that because now I awaiting on the result of the make cake, what's going to happen is with eggs add flour and then sleep 1 hour, right? And I'm awaiting on the exit of the make cake. So now I'm no longer getting the result from the promise and then throwing away. I'm actually taking the promise, and that promise I'm waiting for its completion. So now I'm going to actually wait an hour, right? So doing this stuff, in a sense, is pretty silly in an example, because now I have serialized the whole thing again, right? I have done these two guys, but now I'm sleeping for 1 hour, right? And this guy is going to wait for an hour, and I'm not going to start the second cake until the first one is ready, right? Because of this await, right? But I don't have to do that, right? Because I have this promise result, there are other ways to combine these promises together, right? So one of them is this promise or, which simply means that if I have two promises, in this case, let's say A1 and A2, okay, P2, right? So I'm starting two cakes, right? But now I want to do, let's say that I don't want to do the calculation before I get my cakes, right? And maybe one cake is taking 1 hour and the second cake is going to take 2 hours. So I want to make sure that I get both of my cakes, and I don't want to wait for the first cake to finish before I start the second one, right? So I do want to do this, but now I want to wait. So I want to await, but not on P1 and then P2. So I could, before it was basically this. I want to do a wait on P1, kind of like plus P2 together, right? So obviously you cannot like just write like plus because there's no addition on promises, but there's an API where you can say promise or, and then pass a list of promises. So if you do this, then now you're awaiting on the combination of these two promises, and this itself, the function promise or, returns a promise, and that promise completes. So complete means like exits and returns true, right? When all the promises are inside are completed. So now I'm waiting for the completion of everything before I start the long calculation, right? And then you have a bunch of other ones, right? So the ability of using promises, promises gives you the ability to combine them together, right? And the most elementary way to combine them is to do them sequentially. So you can do the await P1 is await P2 is the sequential way, right? But you can also do the parallel way, right? And this API here, the async await, is the more recent way to do async. Before, you only had this one. You only had promises. So your function would have to be written like this. So let's take this function. So you would have to say make it 2, right? So far so good with game. But now you say sleep is gonna take some time, right? So you know that it's returning a promise. So sleep, you know, is returning a promise. And now you want to do the eat cake, but once the sleep is over, so you have to do the API and then provide the continuation yourself. Right. So these two codes are strictly equivalent. Right? This one and this one. But obviously this one is easier to read than this one. And if you have loops and stuff, then this guy is going to become very, very hard to write, if not impossible. Right. This is by far easier to understand. And in terms of execution, it's pretty much the same. Right. But it's good to know the equivalent, because in this form, you can see very well that the continuation, which is the rest of the function, is only going to be invoked once the promise is complete. Right, so this is quite obvious by the fact that the rest of the code here, if I have other stuff, it would be inside, is given as a callback. Right. And then yes, and okay, and there's other stuff about like exception handling. So what if this guy throws an exception? How do you going to catch them? How you can handle that? So it's a topic that a bit more advanced. Well, it's not super hard, but you can do a try catch actually. And the promise has also something like P2 can be can have also a catch, right, a catch handler. Right? So you can do something like that, right? You catch some stuff. And again, this is equivalent to having a try catch inside an async function. But again, also way more convenient to use try catch than use this syntax, especially if you have loops and conditions. Like if you have something like for something like that, right? Okay, this is not even JavaScript, but let's say you can do something like that, right? Then suddenly it's right, running this well, it's still okay. But if you have that in the continuation, it becomes very hairy. All right, so let's just leave it like that then. So this is pretty much all I have to say about generator coroutine and stuff, right? Yeah, if you have any question, just leave them in comments. It's not as complicated as it looks. Okay, so to summarize, right? The idea is that when you have an async await, the compiler would turn your function into a kind of like a special kind of generator function, which delimitates the sections that are between await, and the sections that are between awaits are going to be normal sections, normal functions. They are not interruptible. You cannot suspend there. But whenever you have a await, you can suspend there. And suspending at a await point means that the value that you get from the right side of the await is something that would come later. So the system, the library, will register a callback when that data is ready, or when that event is triggered. And when that is available, the callback will allow the remaining of the code to resume, right? But in order for that code to resume, it has to find a thread. It has to find basically a CPU where it runs, right? So if you're talking about Node.js, which runs only one single thread, single-threaded, it means that it can only switch between tasks when another one is willing to relinquish control, or there's nothing else to run. So the conclusion is that it can only switch between tasks when you reach a wait point, or you reach the end of the program, right? And if you have more advanced libraries or more advanced execution frameworks, this is relaxed. You can switch from one thread to another if you're talking about different worker pools. But then it becomes a bit more complicated, because if you are in one thread here, for example, what would happen is that you would start in one thread, and then when you resume, so you have this code running in one thread, but when you have this eat cake, you may be running on a different thread, right? So some complication arises if this function has to be on the same thread. So we are not talking about having execution concurrently. So it's just that when you come back here, you will maybe on a different thread, right? So that could be a problem, and that could be no problem at all, right? So maybe in another video, we'll talk about that case, the case where we have different executors. Right? So the executor is basically the piece of code that is going to be able to resume your execution. Resuming execution is not going to be magical, right? Like here, when we were talking about counting a series, you had to have something that actually pulls the next value of the iterator, right? And likewise for this async framework, when you are ready, somebody has to pull and the next task and run that next task, right? So either you use one thread for all, or you use multiple threads, which is like a worker pool, or you have different models. You can have a bunch of tasks that are sharing one thread, and then other tasks are sharing other threads. There's many different models possible. But the main point to remember is that when you are talking about green threads and cooperative multitasking, your resume points are not arbitrary. You have to resume at the point where there's an await, and then you are going to run a single threaded between these points. Okay. All right, that's it. And take a look at the promise API. That's how you combine these things together if you want to run things in parallel, right? Because by default, this is not going to be parallel, right? If we have these two guys here, unless I've done this promise all, this is not running in parallel. But the way Node.js cannot run things in parallel, since it's single-threaded. But if you are talking about a more advanced framework, it is possible that P1 and P2 are running in two different threads. Okay. That's it. Too much talking.